All right. So a lot of time people think that when you take a derivative, you can do it things explicitly. And what's the difference between explicitly and implicitly? So, so for example, if you have um, derivative of d to the dx of x squared, we already know what's d to the dx of x squared. Not 0. 2x, good. Right? But there is something here that we usually don't see. But we're going to talk about that. There's something there that we usually don't see. But it doesn't mean it's not there. It's there. It's not presented. So now I'm going to take first of all, we're going to take a d to the dx of y. What would you get? What's d to the dx of y? Huh? dy dx? Good. Now, a lot of people says, well, what does dy dx really stand for? The d is the change of y over changing of x. Do you see that? D is delta. And that's delta y over delta x. That's the slope, right? And slope is the derivative, right? So that's why the notation comes in. Dy dx is the derivative of function, which is slope of function at any given time. Now, we're going to upgrade a little bit. We says, hey, what's d to the dx of y squared? Well, there are two derivatives. There are the first layer, which is right here. And we're going to deal with this chain rule, and we're going to have this the inside derivative, which is the y. So first of all, we're going to deal with y squared, which is we're going to get 2y, like what we expected, which is 2y. Right? Now we're going to take a derivative y, but with respect to x. So therefore, it's dy dx. Do you see that? There's a dy dx occur. So that's called implicit derivative. Then you say, well, what's happened here? We're going to go back to this question. There was a first layer, which just give you 2x, right? But the second layer is actually dx over dx. We don't write it because dx over dx is what? 1. So that means every time you take a derivative of x squared with respect to x, it's just going to give you like some type of x, right? But if you take a derivative y squared with respect to x, then you're going to get 2y and then dy dx. Is this okay? So what will be derivative of 3y to the 4th? Yes.
It's 12x to the third.
No, this is the y. This is the y.
Oh. Yeah, 12y to the third dy over dx.
Yeah, you're a genius. I mean, not ND level, but you're at Lee level.
It's not that.
You're same level as Lee. Is that okay? Then you say, okay, well, how do I take a derivative of this? Sorry, 6x squared y to the third. So what we're gonna do is we're gonna take a 6 outside like this because we know it's 6 this. Now we're just gonna go focus on x squared y to the cube. What kind of derivative, what kind of rule you're thinking of here? Product rule, because you have two things multiply each other, right? So what I'm gonna do is I'm gonna take a derivative of x squared. We'll just take a derivative of x with respect to x. This is fairly easy. So that's gonna be 2x. Is that okay? Times y to the cube. Is that too hard? plus we're going to take an x squared alone, and we're going to take a derivative of y cubed. What's derivative of y cubed? And what else? So that's what people usually forget. Now we can distribute that. So it's going to be 12xy to the cube plus 18x squared y squared dy dx. Question about this? X squared y squared. Yeah. Okay. We're going to take a derivative of this. Okay, you're going to say, trust me, it's not as difficult as I say. X, this is square. So what I'm going to do is I'm going to take a derivative with respect to x, because our goal is to find dy dx. Because we say, hey, can you find dy dx or f prime of x, right? Can you find either or? So what we're going to do is we're going to take a derivative with respect to x. In terms of x squared, how do I take a derivative of x squared? Is what? 2x. Very easy, right? Now we're going to leave that negative 8 outside here, and we're going to put a parenthesis because we are taking derivative of x squared y to the 4. We're not going to worry about negative 8 because it's harder to think about negative 8s over there. I'll just split it up and I'll put a parenthesis. I'll distribute later. I think that's going to make your life easier, but that's me. Some people do it all together. I like to do it this way. So that's derivative of x squared y to the 4th. So derivative of x squared is going to be 2x, right? Times y to the 4th plus what? X squared times what? 4y cubed, and then don't forget the dy dx. Is that okay? And then minus, what's derivative of 5x? Is equal to, what's derivative of y squared? 2y dy dx. And what's derivative of negative 2? 0. Good job. So then you did it, the implicit derivative. Now we just have to evaluate for it. So I'm going to distribute this 2x minus 16x y to the 4th minus 8 times 4 is 32. Is that okay? X squared y to the 3rd dy dx minus 5 equal to 2y dy dx. So I'm going to circle this. This is what we're trying to isolate. So I'm going to move this term to the other side. Is that okay? So 2x minus 16x y to the 3rd, y to the 4th is equal to, minus 5 equal to 2y dy dx plus 32x squared y to the cube dy dx. Am I going too fast? I'll move the dy dx term, related term on the other side. What we can do is we can factor out. I'll divide it over. And that's why I say work downward. Some of you guys work sideways. Max still working sideways still. I need to work downward because yes, it's tedious. It's easy to track up than going this way. So going downward, practice your math going downward. Nobody doing math sideways like this. It just doesn't make sense because you cannot go back logically track the same step. Is this okay? This dy dx is the function. Now the reason why you want to use implicit derivative, two situations use implicit derivative. One, you got y to the other power than 1. Second, you have mix between x and y together. In this case, you got both. You got y to the 4th power, you got mix the x squared, y squared. So here is the reason why you gotta use the implicit derivative, because of y to the multiple power, and also the mixed term between x and y. And in this case, you cannot isolate the y by itself, because if you do it explicitly, is isolate the y and take a derivative of the function. In this case, it's not possible to isolate the y. No way. There's no mathematical way to isolate the y. Okay, so this is why you're doing implicit. So I'm gonna ask you to try one. Okay, so I want you to take a derivative of this. Actually, hold on, let me change this to the 3rd power. 6x to the 3rd power. So 4x squared minus 5x squared y equal to 6x cubed minus y squared.
What was the other situation in which you used this?
So you have y other power than 1.
Yeah.
And you have a mixed term, mix x and y. So that's a x squared y to the 3rd. And that's the time that you should consider implicit derivative. And implicit derivative is invented by Gottfried Leibniz, which is another person that is inventing calculus that don't get the credit for.
For the little fun fact.
Isaac Newton is the one that get credit for a lot, so nobody knew about Leibniz. But Leibniz is contribute that the part that Newton cannot do. So. Today's homework, I'm gonna give you answers so that way you can check whether your dy dx is correct. What time we get out here? 3 minutes. That's enough time. We're gonna do it together here. You can finish it out. You can do. If I derivative 4x squared is 8x, is that okay? I'm gonna leave the 5 out there. I'm gonna take a derivative of x squared y, which is 2xy plus x squared dy dx. Do you have this part? Equal to 18x squared minus 2y dy dx. Do you see every time you deal with y, you're gonna have dy dx? Yes?
Why don't you put a y before x squared dy dx?
Which one?
Like the first parenthesis.
Yeah.
It says x squared dy dx. Why
Yeah.
Put a y between?
Because I already take. I'm gonna focus on x squared and just take a derivative y respect to x. So that's how I get dy dx. Y is gone because you take a derivative y respect d to the dx.
No, like I'm not. Wait, where did the 2 or the x squared?
Because it's a product rule. So I take a derivative of x squared first. I got 2x times y And then I'm gonna leave the x squared alone and just take derivative y, so it'd be dy dx. Is this okay? So I'm gonna move the 18x to this side. So ax minus 18x squared minus 10xy. And I'm moving everything on the other side. This and this, I'm gonna focus on one side. So I'm gonna fact dy dx while at it. So it's gonna be negative 2y plus 5x squared. Is that okay? I factor out, I do all the same steps. So dy dx is equal to 8x minus 18x squared minus 10xy over negative 2y plus 5x squared.